Oh, hey there, little buddy. What are you doing down there? Do you know what day today is? That's right. It's Make a Fair Day. This is Samuel's project, the smartest typewriter. It's a typewriter hooked up to GPT-based chatbot, so you can type and have a conversation with the AI.
Yeah, this is a crazy idea I had a few years back, and I finally had time to implement it. Basically, it's just an Arduino at the heart of it, talking between the typewriter keyboard and the computer. And that lets me use the typewriter as basically a printer. So I can do things like ASCII art, so Monash Make a Fair logo. But in this case here, I've got to set it with a connection to the GPT chatbot, so you can have fun and have that physical experience with a virtual AI bot. So GPT, it's a massive language model, and you can feed it prompts and it can then complete responses. And you can use it in this way to have a conversation. So you feed it a conversation, you give it a conversation with your prompt added, and then it will auto-complete its response in that way. So it's using a very complex tool for a very simple task.
You can come to the meetings and meet like-minded people and get advice.
So I randomly ran into my old friend Mitch, who I haven't seen for a few years, and he's now he's got this really interesting little project, autopilot for a boat. Is that what this is about?
Yeah, that's right. Yeah. So just like a car, if you're driving a car, you take your hands off the wheel of the car, well, you're going to end up in the weeds. And the same thing is on a boat. I've got a boat which I lived on for 5 years. I sailed it to Hobart and back to Melbourne solo. And there's a lot of times when you got to go and look after something on the boat, or long periods where you don't want to be standing at the helm for long periods because it's very tiring. So you want something that's going to keep the boat running in the same direction. And so I found on the internet a project called typewriter, pypilot.org, that is the software and the schematics for an open source autopilot for the boat. The autopilots on my boat had both failed. I had 2 redundant units. They were both old. They both failed. And if you go to my autopilot units for boats out there, they start at thousands of dollars. Mm-hmm. We're talking 4-digit price tags. So I looked around for an open source autopilot project, and there's a really, really well-established project that integrates with boat electronics and chart plotters and all that kind of stuff, and it's open source. And so what I've done is I've taken the schematics for that and done my own interpretation of that. So what I've tried to do is integrate all the different parts of this into one kind of almost like a product kind of thing that I can use on my boat.
Okay, so the original intention was that it was a bit more modular, so there were different things that people would join together to create the overall solution, and then you've integrated a lot of that?
Typically, the architecture of the system is that you'll have something that might be on a laptop or something like that that's got the smarts, and then there'll be a little control box near the servo or whatever, hydraulic ram or motor, that kind of thing that's driving the rudder. What I've done is I've integrated those into one part. So it's kind of a low-end solution that in one end you supply 12 volts, and the other end it'll drive a DC motor which is hooked up to the helm to turn it.
Okay, so in this case the Raspberry Pi is taking the place of the logic that would normally be done in the laptop or whatever other PC.
That's right, that's right. So on the board here, I don't know if your viewers are going to be able to pick it up.
We can zoom in on this later.
Pi here that does the control logic, has the autopilot algorithms and stuff. It also does Wi-Fi so that you can hook it up to your chart plotter, and there's a web interface so that you can drive it from your phone. Mm-hmm. And there's also 2 other Arduino Atmega 328 chips on it, same as in the Arduino. One of them does the PWM control for the steering motor. Yes. And another one looks after interfacing to the rest of the boat, controls ambient light detection, overload detection. So it's really an integration of 3 separate computer systems here.
Very interesting. So you've got a couple of modules on there. This looks like a motor driver module, is my guess.
That's right. This particular chip was designed to operate windscreen wiper, not windscreen wiper, so power windows.
Yes.
Yeah, so
big
this
DC
will
motors.
switch up to 30 amps for a couple of seconds.
Okay.
For my application, I want about an amp continuous. So the motor that's hooked up to the helm on the boat, to turn that, I need about an amp.
Okay. And so for a project like this, I assume you obviously need you need orientation. Otherwise,
That's right.
you don't have an autopilot. So does it have any GPS or sense of position, or is it purely based on heading and orientation?
This doesn't have GPS, but it's one thing. If you've got GPS somewhere else in your boat and you've got it hooked up, it could get GPS from that. Typically, though, if you want to, typically the basics are that you'll point your boat in a particular direction that you've worked out from your charts or aiming at a particular landmark, and you'll push a button, and then it will act to keep the boat on that particular heading. One of the modules that we've got here is a 3-axis accelerometer, gyroscope and magnetometer that will give the software here an idea of how the boat's moving in space, how it's being rocked around by the ocean.
That's a good point, because you're going to have to filter out all of the motion of the boat.
Right. That's right. So some of the software here that the Raspberry Pi is running is a Kalman filter. It's essentially like a kind of a low-pass filter for the data.
Yep.
To filter out all those momentary rocking around stuff.
Otherwise it's going to be constantly trying to correct for every little movement of the boat.
That's right. It's like a very nervous driver.
Yes.
So there's a mode where you can tell it just to follow a particular direction, and if you were using the onboard motor of the boat to go to a particular thing, maybe that's your option. If you want to optimize efficiency, then you tune the sails on the boat so that they are adjusted for the particular wind. But over a period of time, that wind shifts. Like the wind after half an hour might be 10 degrees different to what it is now. And you might, on long passages, want this to run for a couple of hours. And so if you have a wind sensor, which this thing can pick up the data from the rest of the system, the wind sensor, this will sail to the wind instead of just a heading. Because if you sail to the heading, the boat would lose peak efficiency.
Yes. Okay. So it maintains that peak efficiency by maintaining the position relative to the wind.
Yeah, the wind angle. That's right. That's right. I've got a little buck converter here to convert 12 volts down to 5 volts. Under here, which you can't see, you can see it here, is all the components to do my own buck conversion.
Yes.
I've just put an off-the-shelf buck conversion there to get it going for the Maker Faire today, but as you're saying, it's a progressive integration.
Yes, this is exactly the process that I like to follow as well. You do the very first prototype with some modules wired together, then integrate them onto a carrier PCB, and then over time you end up with a PCB that has just the parts on it that you need.
That's it.
That it gives you flexibility early on.
Yep. The other project that I have today is I like to bake sourdough bread. It's very yummy. Got that lovely tangy taste from the mixture of the wild yeasts and the bacteria, which you grow in a culture. Now, because that culture is less potent than the yeast that you buy for just normal baking, it's critical that culture be really, really active when you start to bake. And so every day you feed that culture with a mixture of flour, which it gobbles up, generates CO2, and the level in the jar rises to a particular point where it's consumed all the sugars, and then it starts to sink again. You want to be able to catch that point. That reaches,
find the peak.
Find the peak, that's right.
Yes.
So this little project that I've got here has a little, it's hard to see there because it's on the other side of the thing there, but it's a little, I think it uses a laser.
It's time of flight sensor.
Time of flight sensor,
yes.
That's right. And the ubiquitous humidity and temperature sensor there.
The DHT series.
Yep. And these are tiny nano boards, I think, from Unexpected Maker.
Oh, it's one of Sion's boards.
Yeah, one of Sion's boards.
Hey, Sion.
Really nice boards. Hey, Sion. So in the same way here, I just use a PCB to kind of integrate different things here. I'm just using this PCB here to integrate an OLED display, the sensors on the back, one of Sion's boards here, and the battery. So the idea is that you stick this on your little starter jar, push the little button there. It's got a little real-time graph on the OLED display there, but you can also watch it on your phone because it's Wi-Fi.
Oh, nice.
It's the internet of sourdough.
Yes.
And so you watch for that little graph to peak, and then you go, okay, that's the moment when I chuck it into the flour and you start your sourdough.
Needs a little more.
Yeah.
And I love the fact that this is just a lid and it's all self-contained. So all you do is sit it on top of the jar and you're done. There's nothing complicated about setting it up.
Again, this is software that I got off the internet, but the integration is something that I've done.
Looks like it's it looks like it's something. What do you like here, Frank?
This structure was designed by Lachlan. Each of these is a long, thin PCB with addressable RGB LEDs on it. And the screws here pass data, ground and power through so that you can infinitely extend this. You just keep adding extra pieces and you can make it longer. And you can concertina because each of these can rotate.
Exactly, that's how it works. The lathe operator is learn to cut. We're both. Ladies who like to just rebuild the car for the sake of it. Blokes who like to knit.
Because Emma had
This is a globe with the vertical features exaggerated in scale by 100 to 1. Normally when you look at a globe of the Earth to scale, even the highest mountains look like just tiny little bumps. And this really exaggerates all the features.
Oh yeah, so
intermediate style because at the moment, like, you can imagine, like, if you try to those, otherwise those have to be made.
wheels are driven.
A lot of the parts we machine ourselves. It's really only about 4 parts.
That's the whole lot I can buy.
Prototype. It's really just a prototype. No, this is a student's work. So, this is his
Well, I've been here for 5 hours. It's back up now. I still haven't seen everything. This venue is too big to get around. Hang on. I can see an R2 unit just over here. R2 is here to say goodbye to us. There goes R2, so it's time for us to go as well. See ya.